Today we'll talk about multi-region fabric. The current Catalyst SD-WAN architecture allows a flat overlay model and establishing side-to-side tunnels directly between sites. While this flat overlay model functions adequately in many scenarios, it does have some limitations. First, centralized control policy is necessary for hub and spoke topology and setting a route preference. Depending on specific requirements of the topology, this policy can be quite complex. Integrating transports from different providers for underlay can be also challenging, so this is particularly relevant to when attempting to leverage middle mile provider or crowd backbone providers network for inter-region traffic. There's a large enterprise that manages MSPs often require SD-WAN to extend to across multiple regions. Now with multi-region fabric MRF, it has some enhancement. Improves OMP transports a true scalable multi-region fabric SD-WAN. There's 3-level customer overlay. They introduce regions, primary access regions, secondary regions, sub-region, where border routers provide tunnel stitching. Inter-region always goes where the border routers. So this lab will gain some insight in the intricate of using legacy approach to create and deploy hierarchical topology within a flat SD-WAN fabric. Our success will migrate from the flat SD-WAN fabric to a MRF fabric with minimal disruption. I will understand the streamlined process for deploying a hierarchical topology using an MRF. And a deploy MRF features such as the second region, transit gateway, and also the policy for MRF. So let's take a look at the site 1 in topology. vManager is site ID 101.1. We have the validator vBond, 4 controllers vSmart. SD-WAN edges, we have sites 201, 202. You have for border gateway west, border gateway east. In each site, we're gonna have the edge hubs, the site 1 and site 2. And we have few branch. This is the hub, the branch edge routers. On the left side, the hub side with branches, they all have the 2 circuits, one to the public internet, one to MPLS. On the right side of region 2, having a internet for site 6000. Site 7000 is going to having a circuit to MPLS. The first task we're going to do is explore flat fabric policy. We'll use the web browser to open the Catalyst SD-WAN. Let's log into SD-WAN Manager. We will discover Fabric Network to ensure all virtual nodes are reachable. Click the hamburger menu, go to Tools, and Discover Network. And I'll mark all of the device and Discover. Here are predefined topology region, hub, and spoke BGP core policy. On the right, and we're going to select the preview. So this region, hub, and spoke BGP core policy adjust the control panel, allow full mesh intercommunication among all sites within the west region. Although within the west region, site 201, 1010, 1020, 3000, 4000, 5000, right? This will prevent direct connectivity to the east region, and so we will achieve it by denying T-lock and utilize T-lock rewise. The west hub 201 connects to the east hub 202 through the BGP core network using a service-side VPN. So as you can see, it is a complex policy even for very small environments with saying 2 transports used everywhere. Next, I will examine the BFD tunnels from the spoke sites. So at spoke sites in the west region site 5000 will not have a BFD tunnel to spoke sites in the east region, such as the 6000, such as 6000 and 7000, right? So from the SD-WAN manager, we'll navigate to monitor and device. I will find edge branch 301. And I'll click on the device and choose real time. In the device option, output is the OMP receiver T-locks. And I can see there are no T-locks to any sites in the east region, and there's no tunnel to any sites in the east region either. We can confirm this by looking at the BFD sessions in the device option. I don't see the east T-lock IPs like the 101.60.1, 101.70.1, or 1.1 202.1, 1.1 202.2. For next step, we're going to review is the IP route. So route table from the spoke size. A spoke size in the west region, like 3000, 4000, 5000, doesn't have a direct tunnel to spoke sites in the east, like 6000, 7000. But it learns the east region spoke prefix with the next hop pointing to the west hubs, like site 201. We're going to go feature the IP route. As I can see, like even though it doesn't have the tunnel towards the east sides, it had prefix for such sites, but pointing to the west hub site 201 T-locks IPs instead of originators. This time, let's filter out of VPN 10. We're going to review the path between the spoke sites. So to confirm paths for communication between spokes in different regions, I'll run trace routes and ping to test the reachability of the Ubuntu between the branch sites in different regions. The tool we're going to use the M Remote NG on the desktop and the selective VPN 3000 Ubuntu and open the RDP session to the host with a password to ping and trace to the Ubuntu host in the site 6000 with IP. I think it is 10.60.1 or 101. Pin. From the trace routes, even the site 3000 and site 6000 have public internet transport in common. They do not communicate directly to each other. This because the active control policy forces traffic going through the hubs, and then the BGP core has highlighted in the in my here. The 172.16 nodes. So you see right here, BGP cores. Next, I will check the route table on the west hub side, bench west 1. That is this one. 1.1 to 201.1. And we're gonna to filter out the VPN 10. Still go to device. Find a router, real time. Now you're seeing the routes from prefix from the east region are learned from the BGP core. This is the host routes. Go down. The 60, 70s. See 60, 70s, 70, 60s. The next task will prepare MRF migration. So I will perform some prerequisites before migrating from flat SD-WAN fabric to MRF. This will enable MRF and all query regions, provision controllers for regions. We'll go to the admin and we'll go settings. Let's find out the multi-region fabric is enabled already. Just by default, this multi-region fabrics should be disabled. So after enable the MRF, the next step is to create the regions. So in this lab, I'm going to create the west region and the east region. So upon the creation, the system will automatically assign region ID. The lab here in the west region has been assigned to the region ID. ID is 1. And east region is having a region ID 2. To find out this, we're going to go to configuration, network hierarchy. Region ID is showing as here. In MRF, vSmart controller is assigned to specific region. Based on the size of the deployment, the vSmart controller can be dedicated for a region or for a group of regions. This step, I will have the controller assigned like this. So vSmart controller 1.1.1.3 is gonna be dedicated for the west region. Is the west region 1. 1.1.1.4 controller is my controller 1, 2, 3, 4. Okay. So controller 2, you're gonna dedicate to east region, which is 2. Controller 3, 1.1.1.5, add a dedicated controller for the core, is the ID 0. And controller 4, 1.1.1.6 is the default or flat existing controller serving the whole overlay. Okay. Controller is assigned to region by the region ID list on the controller system feature template. So I'll go to configuration and I'll go to template. So we're going to find the feature template. The feature template we're going to filter type is system feature template. That's what I created. Now I see 4 pre-configured controller feature template. One of each controller. Track this device attached. Controller 4 is attached. For controller 1, template 1, 2, for site 1. So each template is attached with a dedicated controller. Go ahead here, edit. Here, region ID West for controller 1, region West. Controller 2 is attached to region ID East. controller 3, core region, controller 4, has none, is for overlay. So after assigning distributed controller for regions, all WAN edges in the overlay remain unassigned to any region, with controller 4 serving as the default controller for entire overlay. I can verify that by checking the controller control connection of all WAN edges. Let's go to the monitor and devices. I will look the vSmart control column. I can also verify by going to the monitor devices, and I'm going to select we're going to select the device. Still pick that. Let's say branch 301. We'll go to the real time, find out OMP peers. The OMP peers shows only with controller 4, and it shows like the region ID is none. Next task will enable migration mode on the edge routers. So enabling migration mode allows the WAN edges to participate in the region controllers while maintaining their current OMP peers with the default controllers. So this must be enabled on all WAN edges before the MRF migration. So this task, I will enable migration mode on all edge routers for the size 1010, 1020, 3000, 4000, and 5000. Size 6000, 7000. Also, I will enable the migration mode on all the border routers also. First step is to create the new system feature templates for the west edge devices. Let's go to the configuration. Let's find the template. The next we'll create a new system template. So we'll go to the configuration, then templates. Here, already here. Templates. We're going to add a template. The device, we're going to pick the 8000V. But first we're going to pick a future template. So Cisco system. Can name it as the C edge west system. FT. Scroll down a little bit. The location will make a specific device specific. Here gives the variable name system location. The console bound, I'm gonna make 1150.00. Role here. I'm gonna pick edge router. Enable migration mode to multi-region fabric. Here we're gonna to make it enabled. Latitude, longitude, make device specific. The location console bound rate, latitude, longitude parameters are not mandatory for MRF. However, I define them for lab consistency. Click Save. The description here. Save. Now we're going to create the 4 more templates for the Edge DC DT and the size 3000, size 4000, size 5000. So, well, first to find that templates were created. Make it copy. DC DT, copy. See edge site 3000. Oh, I'm sorry, I should not create this. Go to device template. For the device template, I believe I already created. They will be C edge DC DT. It's here, and site 3000. Site 4000. Site 5000. Device template, feature template, all created. And I can see the DC-DT has been assigned to the DC1, the west, and east. It's right, it's in here. The site for DC-DT is the DCs. $3,000 DT, and I'll do one thing for just to find the device template for the DC 1010, 1020. We're gonna find CH DC DT templates, and I'm gonna say add it. Find here next to Cisco system, we're gonna find the template we created. Choose this one, See Edge West System Future Templates. Click Update. I should see the next screen with 4 DC devices with a little green check mark right here. Click Next, and it should see the next configuration being applied to all 4 DC devices. Scroll down. We are going to find what's changed right here. Migration mode enabled. Role is the edge router. Let's click configure devices. Confirm. Next, I will repeat the steps to apply the same new feature template to C Edge site 3000, C Edge site 4000, and C Edge site 5000. Find 3000, edit. It is Central. We're going to find that template. Click update. Size 3000 is the port. We're going to change the template for 4000, size 4000. It's the central. I'm going to pick this feature template, update. Lastly, we're going to change the template for size 5000. Alright, next step, we're going to create a new system feature template for East Edge devices. So we'll go to configuration and steal the template, feature template, add new template. Cisco 8000V. Template name is C Edge East System Feature Template. The location I'll make is the device specific and populate system location variable. Find the console. Role. Edge router. We're going to enable migration mode to multi-region fabric. Also the latitude, longitude, save it. Change it to device template. We're going to assign the system feature template name like C-Edge Edge East system feature template, and creating the previous step into all the eastern sites and the corresponding device templates. They are going to be I'll just type in 6,000 C-Edge site 6,000 device templates. I'm going to edit. On the Cisco system here, we'll find is the East update. We're going to repeat the same step to site 7,000. Find 7,000. Now I have enabled migration mode on all edge routers, but since I have not assigned the region for each edge routers yet, the edge routers will only pair with default and flat controller. We can benefit that on the monitor device. I need to find branch 301 and find the real time. Typing OMP peers. As I can see, the edge branch 301 has only one OMP peer, which is the controller 4. 1.1.1.6 serving as default and flat controller for entire overlay. Note that the region ID is none. This will change later. I'll pick up the eastern site branch. And it only has a peer with the controller for default. It's a default and flat controller for the entire overlay. The next step is to enable MRF on border routers. In here, I will enable the migration mode on all of the border routers. In addition, I will apply the BGP migration community and MRF on all border routers. This BGP community is needed to avoid routing domain groups with OMP prefixes on default and flat controller being distributed into BGP core, then will re-originate and redistribute it back again, but now to the region-aware controller as shown this diagram. This is because the region-aware or MP routers are preferred over the default region OMP routers. The BGP community will define using is the 12 in additional manner on all of the border routers and the PE routers. So the same community will be used for OMP to BGP redistribution. So first step is the enable draft mode on all border routers. We'll enable MF on border route that requires the multiple features, templates changes which are traffic disruptive. To mitigate the impact, I will enable the draft mode on all border routers at a site 201 and 202. This will minimize the disruption that these changes might otherwise cause. To do that, navigate to configuration in the template. Refine the device template 201. Let's enable it to the draft mode. After that, we'll go to the feature template. I'm going to look for VPN-10 BGP feature template, and let's add it. Scroll down here, I'll find the propagate community, and we're going to change it to on. And then under unicast address family here, we're going to click the pencil. Say match mic com. Save the change. Go down and find neighbor. Edit. We'll make the route policy out global. Is to enable outbound route policy. In the policy name field, we're going to enter append MICOM, which is predefined on the localized policy for simplicity, and I'll click save. Click update. Next. Click configure devices, and you will see the generate draft config for all eastern and western border routers. Click OK. Well, then configure MRF on the western border router. go to configuration, template, feature template, and we're going to create a new template. Name is the 8000. Cisco. We'll name as C Edge Border West 201 System Each template. In here, we'll make a location a specific. Longitude. Latitude. And find a console. Bound rate, change it, and also the role. Edge. Sorry, it's gonna be choosing a border router, and we'll be enable migration mode to MRF. Next, we'll go find a region. We'll pick is the west region. After that, we're gonna change enable migration multi-region. Change it again. Change it from this enable from BGP core. Okay, and community put a 12. Okay. Click save. Go to device template. We're going to find C Edge Site 201 DT. DT. That's edited. In the system here, let's choose the one we created previously. It is C Border West 201 System feature template, and click update. So this will configure the BR West 1, and the BR West 2 as a border routers. They are border routers facing the west region. So, and confirm the config diff section that now both west hubs are assigned to the west region 1. Then here, west region 1, and acting as a border router with the migration modes enabled from BGP core. Configure devices to push the changes. Because the Edge Site 201 template is still in the draft mode, it won't make any change until we disable draft mode. Next step, we'll configure MRF on the east border routers. Now let's repeat the same process for the east border routers. On the feature template, Gonna do create a template. This is central location. Console. Region. Pick Eastern region. The role. Border. We're gonna to enable from BGP core. And community is 12. Latitude. Longitude. Save. Then go to device template. We're going to find is the site 202. Edit. The template I'm gonna pick is the Eastern. Click update. Then the next. Let's confirm diff. Configure diff section. Now both west hub assigned to the east region 2. I don't see the region. Go back. Back. Still find cancel that. Okay. Go to template. We kind of missed something here. Is the region we're missing? Okay, we have region, Eastern region. Do that one more time. Okay, update. And confirm that one more time. Okay, now the region has been assigned for the East region, and its border router. We enable from BGP core migration to MRF config confirm. Because the edge side 202 device template is still in the draft mode, we won't make any changes until we disable the draft mode. Next, we'll enable the private 1T lock as a core transport on all border devices. So this template is gonna be applied here. It is for the C edge side 20x to 20x, and for the VPN 0, private 1. There's a core transport private 1, which is shared by all border devices. So let's find this out. And the template. Gonna be the future template. Find this template. C edge side 2x VPN 0 private 1 child interface future template. Okay. Add it. So after a while, before we load up, under the tunnel section, scroll down under advanced options. In here, make global on the enable core region. Enable it. Click update. This enables the private 1T lock to serve the core region. I will see the config diff. Finally, let's click config devices to push configuration changes. Because all border routers are in draft mode, it won't make any change until we disable draft mode. Let's open the Ubuntu host VPN 10. And we'll keep in this session the host in the eastern region, and I will leave the ping running for connectivity tests to measure the impact of the change. We'll then go to configuration and find the template. We're going to find template site 201, and we'll say disable draft mode. Disable. Click next. Okay, config. Now we're going to disable another template. It's going to be 202. Also, we're going to disable draft mode. take a look the pinging has some disruption, packet loss, and it still keep running after we disable the draft mode. After that, we're going to verify the OMP peer or the borders. Let's go to monitor devices. We'll find a device to BR West 1 under real time. Look for the OMP peers. Because of the peers configuration on the West hubs, I can see the OMP sessions to controller 1, West region 1, and controller 3 for core region 0, and default flag controller 4 that is being used for migration. Let's go to real time again. This time we'll pick border router East 1, still under real time. And this time I will see the similar OMP peers with the exception of the controller 2 that serves the East region, which is 2. Now modify the centralized control policy to allow border routers to receive the priority 1 T-locks of each other. This creates the fabric for the core region. We'll go to the configuration and the policies. And we'll activate pre-configured OMP core TL's T-locks policies. Click here and activate. Activate. Let's review the centralized policy I just activated, where I now advertise the core private 1 T-locks between the border routers, besides its respective region hubs and spokes logic. The next task I will assign the regions for the West and the East edge routers in the side 10, 10, and 10, 20, side 3000, 4000, 5000, 6000, 7000. In the migration mode, I enable migration mode on all edge routers without assigning a region. I verify that edge routers only peer with the default flat controller. After this, I will see the edge routers from OMP peers with new region controller, in addition to existing OMP peers with default flat controller. So to do this, I'll go to configuration and go template, find feature template. Feature template, C edge west system feature template, find edit. First, I'll mark the global region on the region parameters. This one I chose the West region. This is because all devices in the West region peer to the controller 1 and for Western region, and in addition peer to the default flat controller 4 that is used for migration. Click update. Click next. I find region 1 is configured. Configure device. So this will apply changes to all devices in the West region. When you do next, I repeat the same process for the East Edge devices. So we'll go to configuration, still templates, and the future template. Find the East system. I try to edit it when I make the region parameter as global. Finish. And make East region. This will enable the device in the West, in the East region to peer controller 1 for Eastern region. In addition, peer with the default flat controller 4 that's used for migration. Okay. Region 2. Configure. To device. It's the size 6,000, 7,000. Okay, now let's verify when peers on the edge devices. We're going to jump to the monitor devices. Let's pick my favorites. So after enabling migration mode on the edge devices still only peer with the default flat controller 4. Now I should see the respect regional controller in addition to default flat controller in the OMP peers. It's real time. Here you go. And we'll check another device. That's branch 601. This size 6,000 in the East region. I should see the OMP peer with the controller 2. Here you go. For the next task, we'll have all edge routers and border routers paired with regional controllers. We have done that, and we'll complete the MRF migration. So this task will clean up the temporary policies and disable migration mode. After all devices are moved to MRF, the flat default controller can be repurposed to our region. So I will repurpose controller 4 to region 0's controller. Let's go to configuration, template, future template. We're gonna look for these VPN-10 BGP LT. Hub. Okay. Let's remove root map that I completed in previous task. So let's add it. I shall find is the unicast routing right here. Click edit. Let's remove this. Change default save. Under neighbor, let's remove associated outbound route policy. Change your route policy out to off. Save it. And update to trigger the configuration change. Save. This will remove the root prevention BGP route policy I applied in the previous all 4 border routers. So next step is disable migration mode. We'll go to the future template again. The one we're looking for is the West 201 system FT West 201. Should be this one, and click edit. Let's change enable migration mode to multi-region fabric field to default. This will disable the migration mode, and so the west border routers will keep OMP sessions to west region aware controller like a 1 and the core region controller 3, but will remove the OMP peer to a default flat overlay controller for use for migration, right? And click update. Okay, we have disabled migration mode on both west border routers. That will repeat the same process to disable migration mode for the east border routers. We'll go to the same place. Do the future template. That's east 2. Okay, border. The same place where I go to change the enable migration mode to the multi-region fabric fields to default. Update. And we'll disable the migration modes. So the east border router will keep the OMP session to the west region aware controller 2. So basically we're doing this one is to the controller 1, this part is controller 2. So we are changing the 2 devices to the eastern region. This step is to disable the migration mode. So of this site 6000 will change to controller 2, and remove the pair to the controller 4. Now waiting the step to complete. Okay, as MRF by default makes the inter-region connections to via core region, the centralized policy configured for the fabric becomes unnecessary now. Let's deactivate and the current centralized policy and remove the BGP core between the borders. So to do this, we need a we hit here. We don't no service in the core region, because I will remove the service VPN and BGP in the core in the region here. So OMP now. So go to configuration and policies. Find the policy OMP core TLOC policy. And we'll go ahead to deactivate. I can remove the BGP core by shutting down the service VPN 10 interfaces on all hubs, and we used for the BGP core. This ensures the inter-region communication uses fabric created at a core with private 1 TLOCs. So configuration template, find device templates, site 201. Now we're gonna make a change device value. Click shut down. So we shut down the VPN 10 child interface 1 interface on both border routers, branch 1 West 1 branch, border router West 2. This will be shut down. Next. Okay, I'll just go ahead and repeat the same process for the edge side 202. This site. Template. In the remote desktop, I can verify the connectivity between the size 3000 and 6000, and that's do ping. Okay. And trace route. As I can see now, both are still reachable and traffic is still going through the fabric we created in the core, but now without such complex central policy. As for now, I have fully migrated my overlay from a regional hub and spoke using control policy to a multi-region fabric without control policy.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget